Good evening, students. Welcome to today's class. How are you all? As I can see, there are a lot of students who have joined. Good evening, Bellary students. Good evening, then Davangere students. North Canada students. Good evening, and Suhaib. Good evening. Suman. Good evening. Let me know in the chat with a very good, like at least wish from your side too. Let's say a good evening. Can I know a good evening? Okay, nice, Suman. Very good. How are you? How are you, Suman? Yes, and students joining from YouTube. Good evening. How are you all? Okay, I'm good. I'm good, Suman. I'm getting better now. Had some health issues and all, so but it's good. So we'll be starting our session correctly at 6:45. In the meantime, students, let's do one thing. Let's check our audio and the PPT presentation that is visible or not. Okay, audio is audible or not? Is my presentation visible or not? I'm launching the technical check. Students, let me know. Let me know in the chat. Let me know through the poll also. Is everything fine? Everything, the audio, the video, the presentation. Let me know, students. Yes. Okay, so everyone has answered, and as I can see, there is no issue. Very good. Sweetie, good evening. Welcome to today's class. How are you? Good evening, Davangere students. Yes, sweetie. Very good. So yeah. So let's do one thing. Let's wait for one more minute. Okay. Then we'll be starting our session. Okay, students. Yeah. So myself, who am I? I'm your physics faculty from Avantifellows. My name is Samanvit. And see, we were talking about what? Newton's laws of motion. Yes. So in the meantime, students, certain students were asking for books which can be referred. So I prefer these books. You can prefer. Okay. It is Sipande, Pradeep's, and RLS Physics. See, in market there are a lot of books, and if you keep on, let's say, seeing a lot of books, then you will keep on confusing concepts. Okay, because there are certain people who will teach you the concepts in a different way itself. Okay, but ultimately they are telling the same thing but in a different way. So make sure that, see, if you're sticking to one book, stick to that book itself. Okay, don't move from one book to another. Is it good? Okay, so students, then if that is the case, then let's begin on today's session. So before going ahead, let's quickly go through what we are going to study today. So there are a lot of things to study today, students. First thing, obviously, what? The quick recall. There'll be a quick recall. And based on what we are studying in the last class, there is a question also. So I want everyone to try that question also. Is to make sure that, okay, you have been keeping like up to date. You're studying everything. Okay. Is it good? Then see, in the last class, we also talked about static friction. Then we'll look into it again today. Then there will be a what? Limiting friction. Then we'll be talking about kinetic friction. See, all these are what, students? External friction. Yes, category of external friction. Yes or no? Students, let me know. Yes or no? Do you remember the static friction that we have studied? And lastly, we'll be talking about a friction versus applied force graph. Okay. So it's a very important graph. Sweetie, very good. Okay. And Ballari, Davangere, North Canada students. Make sure that there is a constant interaction. Okay. Suhaib and Suman with a emoticon, thumbs up, or a message. And in the meantime, let's say during the classes, if you feel any doubt, okay, any doubt, make sure that you stop me there. You ask me, sir, this is my doubt. Okay. Then we'll be talking in the summary. Is it good? Now, students, in the last class, what did we talk about? Do you remember? The first thing we talked about was what? A friction. Yes or no? What was this friction, students? What was this friction? Friction is an opposing force that comes into play when one body actually moves. Okay, when there is a movement of the body, and that movement should be what? Let's say if this was the surface and there was the movement of what this mass, there's the movement of this mass, then what students? What this movement should be what? Relative motion. It should be a relative motion. Then only there is a friction in the surface, right? In this point, along the surfaces of two bodies, yes, there is this friction. Yes. Now, or what there even tries to move over the surface of another body. What does it mean? See, over here, as I said, we took the idea of what wardrobe, where if you're trying to push the wardrobe, there was this what, see, initially you put a force, but there was no movement. But if when you increase the forces, then what it moved. At a particular point, there was this tendency, tendency of motion. This tendency of motion will also result in a friction. Yes or no? And we talked about what is this type of friction is. Yes. Then what? Thus, the force of friction is a force that develops at the surface of contact of two bodies. Yes. Yes, students. There was two bodies. Then, if this is the what? If this is the surface and this is this is the body M1 and this is the surface, then at the contact of these two, there will be friction. Yes or no, students? And also, I told you what friction comes in pair. Yes, friction comes in pair. And what was another thing I told? Friction is a contact force. Yes, it's a contact force. Unless, yeah, obviously, if there is a movement or a tendency to move. Yes, is it good? So friction is what? It comes in pair. Yes. And what? The contact force. Unless and until there is no contact and there is no relative motion, you can't expect there is a what? A friction, student. See, over here, if this was the body and if it is hanging over here, is there any friction over here? Let me know. Is there any friction? Is there any friction? Yes, very good. There is no friction. Very good. Very nice. Others, let me know. JNV students. JNV students. Then what did we talk about? We talked about origin of friction, yes or no? Where we saw that the surfaces are never what? Are never smooth. There was some irregularities, yes? Never smooth. There were some irregularities. Irregularities. Now, what are these irregularities? Let's say there are two surfaces. And if this is the one surface, then if this is another surface, surface 2, then what did I tell? This is surface 1, and this is surface 2. Then what did I tell students? See, whenever you keep any two surfaces together, then the area of contact is very, very less. Yes or no? That is what? Point area. Yes or no? So the area that is in contact was point area. So whenever there is what? Whenever there are two surfaces that what touch each other, then you know that there was this pressure that comes into picture. Pressure by area is equal to, force by area is equal to pressure. Yes. And this area is so small, what? It is 10 to 0, that this pressure is very, very high, up to infinity. Yes or no? Now, over here, there was this force that came into picture. That force is called what, students? Do you remember? Do you remember this force? There was this pressure that it becomes very high and it results in this force. Yes, the force of adhesion. Adhesion. Yes or no? Yes, Suman, very good. That force is responsible for what? Friction. This force is responsible for friction. Yes or no? Because if there is, if let's say there are two bodies, and if there, let's say if this is our two bodies, if there is like too much of force of adhesion, then you require more and more force to move that body. Then what does it mean? It means that there is friction, more friction. Yes. And as I told, I gave this force of adhesion for example of what? Fevicol. Check your Fevicol, students. In that it is written, there is a quantity, it is written as what, students? It is written as force of adhesion or adhesion force. So the Fevicol has like certain amount of adhesion force, which will help you to what? Connect two bodies. Basically connect two bodies. you apply the Fevicol over here, Fevicol. So any two type bodies can be what? Mazboot, there are a lot of, you say, advertisement on Fevicol, right? Like too much, it is too strong. Even if you want keep in water, it won't go. So there is a lot of force of adhesion. The good students, let me know. So you remember these things. Then what we did do, we what classified the what friction. So first thing was external friction, second thing was what? Internal friction. Where external friction which arises when two bodies are in contact. If there are two bodies and if they are in contact, then the friction arises. Yes or no? Then there is friction along the surface. Yes, this is the friction. Yes, very good. That is the external friction. And what is said that there is an actual relative motion between the two. There should be a relative motion, and the external friction is also known as what? Contact friction. So I hope you remember this also. And also we talked about internal friction, where I told you that it is between the layers of liquid. Layers of liquid. And I told you this force is called what? Viscosity of the liquid. Yes, it is called viscosity of liquid. Don't worry, we'll be talking about it in what? Fluid mechanics. In fluid mechanics. Mechanics, okay? Mechanics. Is it good? Just a second. Fluid mechanics. Yes. Yes. Then what did we do? We classified this external friction into three types. First one was static friction, second is limiting friction, and third is kinetic friction. This friction is already talked about, and today we are going to talk about these two friction, students. Now, if that is the case, students, what is this static friction? Let me know. Will the static friction come into place when object is at rest? Will there remain any static friction when object is at rest? Let me know. Static. Okay. This is the external and internal friction. Suman, very good. Sweetie, very good. North Canada students, let me know whether can I go to the next slide or not. Okay, can I know? Can I know whether I can go to the next slide? Okay, yes. Madhya, very good. North Canada students, let me know. I'm waiting for you. Krishna, welcome to today's class. Madhya, welcome to today's class. YouTube students, welcome to today's class. Yes, okay, good, very good. Thank you. Now, what? See, static friction arises when what? There is tendency of motion. Yes, there was tendency of motion. This static friction always arises when there is what? Tendency of motion. Yes or no, students? Do you remember what? This static friction, the opposing force that comes into play when a body tends to move. Okay, when there is no relative motion, when there is what? A tendency of movement, students, to move over the surface of another, but the actual movement hasn't started yet. And if that is the case, then there is a static friction. Yes or no? See, over here, we had a body of mass, and then I was applying, let's say, force, different forces. Now, see, in yesterday's class, we came into what? A coefficient of static friction, that is mu s, and there was certain value. And we get to know that Fs is what? Proportional to normal force. And we know that F is equal to mu s into F. For timing, you know this. Okay. Now, as a said, students, see, over here, whenever I am trying to what? Put a force, and this force, if this force is what? Is greater than, or let's say equal to, if when this is equal to the friction force, the static friction force, that is what? Tendency of motion. If there was a tendency of motion, then what? Then there was the static friction that comes into arise. Yes or no? Yes, students. See, over here, okay, this was the maximum. Whenever it is equal to, then it was the maximum static friction. Okay, let's do one thing. Let's take a example of yesterday, then let's try to do it. Okay, there was a force F, okay, and there was this mass, okay, some kg mass, and there was this static friction that we got, the maximum static friction that we got as something, let's say 12 Newton, okay. Then the applying force that was I was applying, let's say 1 Newton. Let me ask you, students, will the body move now? Will the body move now if I'm applying 1 Newton of force? Yes? Yes or no? No. Yes, the body won't move. But students, as I said, this static friction arises when there is a tendency of motion. So over here, see the F static what? The static maximum force is what? Is 12 Newton. But over here, the F static friction that is what being applied is what? 1 Newton, students. So what does it mean? The static friction is what? Is a variable force. Yes or no? It depends on the what? The force that you are applying. Let's say I'm applying what? 2 Newton. Then the static force is 2 Newton. But I'm applying 3 Newton. The static force is friction. Static friction is what? 3 Newton. But until what? Until you are applying what? 12 Newton, students. See, over 12 Newton, what is it? It is the maximum. क्या हो रहा है अभी? देखो, there was a static friction. Okay, there was a static friction. Now you apply 12 applied force. Our external force is 12 Newton. Now till 11 Newton, this static friction is like, okay, my job was up to 11 Newton. Up to 11 Newton, I made sure that this body did not move. But now since you're applying like 12 Newton, and now you're going to increase that what force more than 12 Newton, this static friction will say, I can't handle this force. I can't handle this force. Yes, that is why there was this what? Maximum static friction. Yes. So this static friction had a limit, that is what? From 0 to what? Fs max. Yes or no? You remember these, students? Let me know in the chat. There was this limit which comes into place. Yes. Let me know in the chat, students. Yes, Viti, very good. Suman, others. JNV students, I want a reply from you. No one is replying me. Madhya, Trishna, Ballari students, Bagalkot students. Yes, very good, very good. Yes. Now students, coming into some other things about static friction. What? Static friction can also be defined as, okay, Davangere students, we may also define static friction as the force of friction which exactly counterbalances the applied force during the stationary state of the object. As I said, see, in the previous, I was applying different forces, 1 Newton, 2 Newton, 3 Newton. During this body was not moving. During this, what? The body was, movement was not there. Now, this movement was not there due to what? This static friction which was being applied on the surface. So the value was what? First, if it is 1 Newton, 1 Newton. If it is 2 Newton, 2 Newton. If it is 3 Newton, it is 3 Newton. But there was a limit. Okay, not Canada students, I'm repeating. See, there was a limit up to which we can apply it. Yes, Fs had a limit up to which we can apply it. That was what? Fs max. Let's say the maximum static friction of this is what? This maximum static friction is 12 Newton. See, I'm applying 1 Newton force. It didn't move. The body said, I have my static friction. It is making sure that I don't move. That is, it applied a 1 Newton left side opposing the relative motion, and it applied 1 Newton. Now I applied this applied force 2 Newton. Now also the body didn't move, because why? The static friction is 2 Newton, but there was a limit. See, when I applied 12 Newton, or let's say F is equal to 12.001 Newton. So what was happening? It was increased from the maximum value. Maximum value is 12. Yes, sorry, 12. So I'm applying what? Force to be 12.001. Now what will happen? Now the body will move. The body will move. Yes or no? Because why? Because Now static friction is like, I'm just tired. What I did was till 11 Newton, I could barely, I could what make sure that body didn't move. But now you're applying more than force. I can't hold this, I'm leaving it. Now what, do whatever you want. If you want to move the body, you will move the body. You can move the body. Is it good, students? Did you get it now? Yes. See, over here it is saying another thing. See, over here, we may also what define static friction as the force of friction which exactly counterbalances the applied force. See, over here it was 1 Newton, it applied 1 Newton. When I applied 2 Newton, there was static friction was what? Fs was 2 Newton. If it was 3 Newton, it was 3 Newton. Yes. And also, see, the static friction does not exist by itself. When there is no applied force, there is no static friction. If it comes to play, the moment there is a applied force, okay, whenever the what there is a applied force, then what, there is static friction. North Canada students, let me know North Canada students. Okay, good. Others Bhagarkot students, very good. Okay, very nice. Very good. Now, if that is a case, students, see over here, before going to the problem, see, we know, just a second, we know what, let's say if there was a book, if this is the book, now you can apply a small force to move the book, yes. But if I'm applying a pressure or normal force, then can I move this book? No, right? So can I say this static friction is directly proportional to the normal force? Yes or no? Or can I say this is this maximum static friction that we get? Yes or no, students? Let me know in the chat. Let me know. Yes or no? Now, yes. Now, students, in yesterday, I told you whenever you remove this, what proportionality constant, what will happen? Fs max is what? Is equal to mu s into n, where mu s was what, students? Coefficient of static friction. Yes. Now, students, always remember this coefficient of static friction will depend on nature of the material, temperature, etc. Okay. Always remember. See, over here, if there are two surfaces, then friction, the static friction, that is what, static friction will depend on the nature of the surfaces. Will depend on what? The nature of these two surfaces. Nature. Okay, students, is it good? Let me know. Nature of the surface, like material, temperature. Yes. Okay. Very good. If that is a case, students, then here's a quick question for you guys. Make sure that you solve this. Okay. It is saying, the question is saying, a force of 300 Newton is acted on some box of 5 kg. Put static on the floor. Okay. Now if there was a force of 300 Newton is acted on some box of 5 kg, put static on the floor. If the coefficient of the friction is 0.3, then determine the static friction. Let me know. What is the static friction, students? So I'm giving you exactly 2 minutes of time. Let me know. Read the problem very, very carefully. Okay. Read the problem very, very carefully. Don't simply answer it. Okay. Because it's a trick question now here. So what they're doing is, there was a box and they applied a 300 Newton. What is acted on some box of 5 kg on the floor? Okay. Is acted on some box of 5 kg. Put static on the floor. So there is some force. So this is what? This will be the normal force, students. So remember that. So let me know the answer now. Let me know the answer. Don't get it, students. Madhya, very good. Others, let me know. Ballari students, Suman. Okay, okay. There is a mistake in your answer, Suman. JNV Ballari students. Check your answers. YouTube students, let me know the answer. Very good. Last 20 seconds. Last 5 seconds. 3, 2, and 1. Time up. Okay. So everyone has given the answer, but Ballari and Suman, I guess you need to check your answer once. Okay. See over here, it is clearly saying that a force of 300 Newton is acted on some box. Okay. What? Of 5 kg to put what? Static on the floor. So basically, what they're doing is they're applying a force over here that is 300 Newton on the 5 kg of box. That is how the force is being applied, students. Now, this is what basically, this is the normal force that is being applied to make sure that what? देखो देखो अगर हमें जो बॉक्स है उसको स्टैटिक रखना है तो हमें वी कांट अप्लाई फोर्स हियर. अगर ऐसा अप्लाई किया तो वो मूवमेंट होगा 300 फोर्स, तो वी कांट अप्लाई दिस. देखो यहाँ भी अप्लाई नहीं कर सकते ऑब्वियसली बिकॉज इट विल मूव. The only force that can be applied is along this along this line, that is what, from the normal. So that is the normal force that can be applied to make sure that the body is in what, static. So that if that is a case, students, we want what, F S, that is the static force, static friction force. So that is what, mu S into what, normal. Now we know that mu S is what, 0.3 into normal force is what, 300. So that is what, 90 Newton. Did you get it, students? This is 90 Newton. That is what, the maximum force. Okay, the maximum static friction. If the applied force, if I apply a force is greater than 90 Newton, then there will be what, movement. Then there will be a movement. Let me know, students, in the chat. Ballari students and Suman. Sweetie, did you answer it? Let me know. Let me know. Krishna, let me know. Yes, okay. Okay, Suman, very good. Others, let me know in the chat. Okay, very nice. Okay, sweetie, no problem. Thank you. North Canada students. Okay, I'm not getting a reply from Ballari or Bagalkot students. What is happening there? Can I know? Okay, now coming into today's topic, that is what? That is limiting friction. Now, to understand the limiting friction, see, this is very simple. Okay, because you have already what learned about it. Just that we are trying to give a name to it now. Let's take three scenarios. Okay, let's say I have a body of mass 5 kg. Okay, and let's say the coefficient of static friction is 0.2 and applied force is 8 Newton. Now, I'm keeping the same body. Okay, the static friction is 0.2. Okay, and I'm applying the force now, what, to be 9 Newton. Now, I'm taking another scenario that is 5 kg only. I'm applying 10 Newton and this scenario is what, 0.2. Now, students, see over here, we know that the maximum static friction is what, max, S max is what, students? Let me know. 0.2 into what, the normal force. The normal force is 5 kg, that is 5g. So 5 into 10, That is what? 10 Newton. Yes or no, students? Let me know. Yes. So now you know that the maximum Fs max is what? 10 Newton. Obviously, now you know. Now I'm asking students, when I apply 8 Newton of force, what is this? Applied force. Applied. F applied, F applied, and F applied. When I applied 8 Newton of force, will the body move in the first scenario? In the first scenario, let me know, students. Let me know in the chat. Will the body move or not? Yes? No. Very good. The body won't move because we know that if the applied force is greater than what? F S max, then only the body will move. Then there is movement. Yes. Very good. Then there is movement. See over here, the value of static friction would be what? 8 Newton. Yes. The maximum static friction is what? 10 Newton. But since the static friction is applying the force 8 Newton along this direction, then it is what? Students, then it is what? That is the reason there is no movement. So it will be at rest. Now, when I apply 9 Newton, will it move? When will it move? No, right? It will also be at rest. So the value of static friction is what? Fs is equal to 9 Newton. Because as I said, what? There is no formula to find static friction. There is only formula to find what? The maximum static friction. That is what? Mu into n, mu s into s. And as I said, the static friction is what? Is a variable force, and it is according to the what? The applied force. Now, students, let me ask you, at this position, will there be any movement when there is 10 Newton? When there is a 10 Newton force? Yes. Now, up to 9 Newton, yes, Suman, there is, okay. See, I'll tell you what it is exactly. See, up to 9 Newton, starting friction is like, I managed this somehow. I made sure that the body is at rest. But when I applied 10 Newton of force, then there was this tendency of motion. Okay, there was tendency of motion. There was this tendency of motion. But when I apply, let's say I applied 10.001 Newton of force, then will there be movement? Let me know. There will be movement. There is a movement. So basically it is saying what? Up to a limit, I can hold the object. Yes, the static friction is like up to the limit I can hold the object, and that limit we used to say that what? Fs max. That limit was Fs max. Now, students, this Fs max is basically the limiting friction. So basically what is happening now? If the applied force is greater than the limiting force, so there is movement. Yes or no? Yes. See, up to what? Fs equal to 9 Newton, there was no movement. No movement. But we know that Fs max was 10 Newton. Now, students, I applied what? F applied was what, students? It was 10.001 Newton. Now there was a movement because the applied force was greater than the Fs max, and that is the limiting. Yes. Now, until now, we were talking about was Fs max. Now that Fs max is only the limiting force. And if applied force is less than F limiting, then there is no movement. Did you get it, students? Now, what is this limiting force now? Let me know in the chat. Let me know. Yes or no? Yes or no, students? Very good. Very good. Now, yes, the formula to find what? Limiting friction is what? What is the formula? That same formula, Fs max formula. That is what? Limiting equal to what? mu s into n. That is the same formula. S where n is the normal force, mu s is the coefficient of normal force, coefficient of what? Static friction. Is it good? Let me know, students. Now, did you get the idea about see, I didn't want to confuse you with what? The limiting and the static friction. See, the static friction is basically what? Variable force. Applied, अगर applied force कितना है, उसके हिसाब से static friction आ रहा है. But up to a limit, आपको वो जो ऑब्जेक्ट है वो स्टेशनरी पे होगा, रेस्ट पे होगा. लेकिन लिमिट के बाद क्या होगा? मूवमेंट होगा. बस उस एफ एस मैक्स को हम अभी लिमिटिंग फ्रिक्शन बोलते हैं. इज इट गुड? ओके, let me know. Suhaib, Bhagalpur students, Badari students, let me know in the chat. Yes, very good. YouTube live students, let me know. Let me know in the chat. Okay, students, let me know in the chat. Can you hear me or not? Sorry, there is a network, let's say, issue. So due to power issue, the internet went away. Let me know in the chat. Okay, good students, very good. Just a second. Let me just. Okay, very good, very good, awesome. Thank you for your support. Yes. Okay. Now, so I can't on the video, okay, because there's no light over here. Okay. Now, okay, we talked about what? Limiting friction. Now we got the formula also. The formula is what? Mu s into n. Now, students, we studied everything. Let's like revise everything using what? The definitions. And see, as I said, the limiting friction, the limit. Okay, students, let know if there is issue in the audio. Okay, because there is network issue, there might be certain audio issues. Okay, if you face the issue at that moment, okay, that moment. Yes. Okay. Good. See, as in this stage comes when the body is just on the verge of the set. We saw the body, yeah, and if the max. Network issue. Okay. Students, let me know in the chat now once again. Can you hear me? Can the presentation, is the presentation visible or not? Let me know. North Canada students, let me know. Let me know, students. Yes or no? Okay, Suman, can you hear me? Students, give me 2 minutes. Give me 2 minutes. I'll just set up everything. Students, let me know. Can you hear me? Yes, let me know in the chat. Is it fine? Can you hear me? Can you see the presentation? Okay, good, good. Thank you, sweetie. Others, let me know. Let me know in the chat. Genuines, let me know. See, unless you tell me there is no option, I can't go ahead. Students. Please let me know. Krishna, Madhya, non-Canada students. Okay, okay. Now, let me know. Okay, there are a lot of issues. Just a second, students. Now let me know. Okay, let me know now. Is everything well and good now? Okay, good, good. Okay, okay. Pakana, there's no issue. Okay, students, let's see. Okay, let's do one thing, students. When we're continuing the class, if there are more issues that arises, then we'll be continuing our class tomorrow. Okay. Okay. So because there is this issues in the network because there is no power over here. That is why. Okay. Now, along with that, sweetie, let me know. Can I continue? Can you hear me? Madhya, let me know. Yes. Okay, students. See over here, as we were talking about limiting friction, I was saying that as we increase the applied force, a stage comes when the body is just on the verge of moving on over the other S. If there are two surfaces, and if there was a body, and if I'm applying a force of let's say 10 or let's say 12, sorry, 12 Newton, what was happening? What was happening? There was this verge of movement, yes. And as I said, this static friction depends on the applied force, how much ever it's breaking. Okay, it's breaking a lot, Krishna. No? Yeah, I'm on because there is lot of network. Yes, so we'll be continuing with limiting friction. Okay, is it good? Before ending our class, okay, please answer the NPS poll first. Please answer the NPS poll and even class. Okay. So there are lot to discuss, but the network issues we can't do anything. Please answer the NPS.